down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we have never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical diversion maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of the crater, right beside a 6-kilometer high mountain.
You can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage, it's in a collision course with the rover. We must cut the bridle immediately and fly to the descent stage to a safe distance from the rover.
So that's what's going to happen tonight at 1:31. Actually, at 1:31 in the morning is when that first signal comes back from the spacecraft saying, I've entered the Martian atmosphere and I'm slowing down using my heat shield. By then, like Adam said, it'll all be over. It'll all have already transpired on the surface of Mars, but the radio waves will be coming back and it'll be telling us whether we were successful or not. So the next video I have for you runs a little long, I hope you'll be a little patient, but it starts at the beginning of the launch and goes through that same sequence with a little less drama. But the reason that I show it is for the last minute and a half or so. And the reason is because it shows what we're going to do once we get to the surface of Mars. And so I'll help you with that. I think I may be able to narrate that one a little bit. So November 26th, we launched the rocket. And the Centaur second stage put us on a trajectory to Mars. And separated the stack. We cruised in space for 7.5 or 8 months, I think it was. 8.5 months. That's the upper side of the cruise stage. You can see it's got solar rays on there to keep it powered. We spin it a little bit so that it stays thermally stable because it's getting input from the sun. And then now, tonight, it'll jettison the cruise stage about 10 minutes before it hits the atmosphere. It drops 2 165-pound tungsten weights to get the center of mass off of the center of the stack, so that then we can actually fly it like an airplane through the atmosphere. You can see the jets going off, adjusting the trajectory. So we go from 13,000 miles an hour to about 1,000 miles per hour. We release some more weights. Fire the parachute. Parachute quarter. Chute opens up. We drop the heat shield. That slows us down to about 200 miles per hour. At which time we drop away from the chute and fire up the engines on the descent stage. We slow it down to about the last 60 meters or so. We come in rather slowly, and I forget the exact speed, but it's very slow. Begin to almost hover over the surface of Mars. When we find the right spot, we lower it on a crane. As soon as the wheels touch down, we cut the bridle. And without all that extra weight, the descent stage flies away. I always wanted to put a little boom in the background. All right, so that's where we left you after 7 minutes of terror. And that's where we'll be tonight. It'll be just about Martian sunset when it happens. We'll be on the surface of Mars. We'll get a few images back about 2 hours later, but then the next day we'll start checking ourselves out. And once we're fully checked out, we're ready for science. It'll take us about 2 months to get ready to start doing the science. We'll start surveying the landscape, looking for targets, specific targets that we want to visit. We already have a list. And once we find the exact targets that we want, we have the ability to go in and vaporize some of the rock as well as scrape some of it up. What you're seeing there is a laser that's capable of vaporizing rock at 14 meters. It's like a weapon. And what that does is that releases the gas that was trapped when that rock was formed. And we can analyze that gas in a spectrometer. And that will tell us a lot about what was going on in the climate of Mars when the rock was formed. We also have drills and brushes and all kinds of really neat geological tools on the end effector. Then we have these scientific instruments, these spectrometers, that actually take the sample, they put them into vials, and they're heated up using a laser. And we look for the various spectra, so it'll tell us about the elements, the composition of the rocks that we found on Mars. That's actually this is all going on in the belly of the rover. And what we would normally do if we had the sample here on Earth is exactly this, but we do it in a laboratory with a much bigger instrument. So that's what the science is going to be about on Mars once we land successfully tonight. It's not easy. I had a boss one time when we were landing Phoenix that said, "This is not a trip to Grandma's house." Gave me pause for a moment, but I finally figured out what he meant. It's not easy. There have been 40 attempts to land at Mars. 26 have been failures. 14 have been successes. The question to the kids here is, tomorrow morning when you wake up, where's the next number going to be? Is it going to be over here? Is it going to be over there? I've done everything I can for the last 7 years to make sure that that number is 15 and not 27. So that's what's happening tonight at 1:31 in the morning. What I want to explain now, real briefly, is that if you're a kid and you're watching this go on, you might begin to think that it's all about Mars, or that we've done everything that there is to do on Mars. The truth is that there's lots to do to explore our solar system. And I've got 3 examples here. This is Venus on the left, and Europa in the middle, and Titan on the right. Titan is a moon of Saturn. If it weren't in orbit around Saturn, it's so big it would be considered a planet. The interesting thing about Titan is that it has a hydrological cycle, evaporation, condensation, precipitation, and accumulation. And it's raining right now in the southern hemisphere of Titan. In fact, that lower bluish, purplish blob in the lower right-hand corner, that is a sea as big as the Black Sea. You don't see all of it. It's about the size of the Black Sea. But it isn't water. It's methane. It's got a hydrological cycle that's methane. I don't even know how to make a word out of that. It's methological, maybe? But the way to explore Titan may very well be through a boat. Can you imagine landing a boat on Titan? The way to explore Venus, which has temperatures that will melt lead on the surface, and on the way through, you go through a layer of sulfuric acid. The atmosphere is laced with sulfuric acid, and the pressure is so intense it'll crush normally constructed things, tin cans and everything else. The best way to explore Venus may very well be through a guided balloon. And Europa. Europa is this place where if there's life beyond Earth, if there's life out there, it might most likely be under the surface of Europa. An ice shell, a kilometer thick, in orbit around Jupiter, bathed in a radiation belt that's so intense that if you stood on the surface, you'd receive a lethal dose of radiation in just 48 hours. But the way to explore Europa is to go under the ice, to melt your way through a kilometer of ice. And then when you get there, have a submarine. So it isn't just about rovers. It's about getting there to be able to explore and to do the science. It could be a balloon, it could be a submarine, it could be a boat. There's plenty of room to explore our solar system. And in order to do that, just as an aside to the kids, you've got to study science, you've got to be able to do math, and you've got to learn to communicate. So, I always like to end with this slide. This is a slide of Saturn. It's backlit by the sun. It's an amazing picture just scientifically because it lights up the rings in an unusual way that then allows the scientists to see features they've never seen before. Just to give you an idea of size, if you could measure the distance from the left-hand side of this ring to the right-hand side of this ring, it would be 28 Earths strung out like a string of pearls. That's how big the rings of Saturn are. But they're so narrow, so razor thin, that they're only as thick as this building. They're 28 Earths wide and only as thick as this building. But looking through those rings, the Cassini mission saw in that little red circle there a blue dot. And that's us. That's Earth. It kind of makes me feel just a little bit small. But when you actually think about it, it represents an accomplishment. It's an accomplishment that we've come this far. And it gives me a sense of awe to think of just how much further we have to go. I live for the day that when it's not a robotic spacecraft that takes that picture, but it's a human that takes that picture. And that's what I think is really our destiny, is to move beyond the Earth to become true space explorers. It starts with robots, it continues tonight with MSL, and it will continue throughout the rest of our lives and our careers. So that's my talk. Let's see, that's all I have. Thank you very much.
Ladies and gentlemen, we have time for questions, right? Yes, we do have time for questions. If you have a question, raise your hand and I'll try to get to you.
Let's see, that Sherry and Eric are both on the same side there. Okay, we'll go over here.
If your radio signal has a 7-minute difference